From my perspective, Web of Things as a standard have failed because the IoT as a new movement also failed.
Oh my God.
The real use case is also not there for Internet of Things, right?
The industry went the other way.
Hi, everybody. We're back to our podcast talking about different IoT topics. And today, as usual, our dear
Ivan.
and Alexandra from Staex, we're here to cover another topic. And today we actually chosen to talk about something interesting. It's for us the start of 2024. And we picked the topic of Web of Things. Different terms have been around: Internet of Things, Web of Things, Industry 4.0. This is especially what a lot of people are working in Germany specifically. We're gonna discuss what is the status of the Web of Things, what are maybe some of the standards that are prominent in the space, and most importantly, how you can use it in maybe your systems, or as we as users, which use cases are actually available or maybe not available with regard to the Web of Things. Ivan, what is Web of Things, and how do you understand this term?
Yeah, Web of Things is a W3C standard for communicating with IoT devices. And they have all the usual components of W3C standards, like all of the web technologies, like HTTP-based access to the device. So in this standard, each device has an API, and through this API, through this REST API, HTTP API, you can access the device. You can send the commands to the device, and you can monitor your devices. And the communication format is usually JSON. So it's pretty standard web technology. I don't know if it's a regular standard or recommendation. I know that there are a few implementations of this standard. I'm not sure how it's popular. I know the implementation by Mozilla, which was discontinued at some point. And there are many alternatives to the standard, which I used mainly for private, by private individuals for their smart homes. It's Home Assistant, the most popular platform, and many others like Domatics, and I even forgot the names of others. But Home Assistant is mostly the most used platform, which is alternative to this standard.
Okay. So maybe because you said it's a standard and it supports the HTTP communication between the things, so to say, on the internet. Maybe you could talk a little bit for the audience. If you want your devices to enable speaking this standard, what is actually needed on the device, how you can enable this from the W3C perspective.
I believe that you can implement it either on the device or on the maybe router or the server to which device is connected.
Okay.
So you can access the API gateway, and this gateway then routes the traffic to some other device, or maybe it can communicate to the device using some non-standard protocol, and you will not see this, you will see the nice API. I think this was the main idea behind this standard. As for the why it's called Web of Things, the idea is that you have some intermediate node, like the gateway, between the device and the client that want to access this device. And since you have this, since this gateway can be on the server, you can protect the server from all the internet threats much more easily than the device, especially from denial of service attacks. And also you can hide the real IP address of each device. So, for example, if these devices are in the field, they use 5G or 4G connections, they have some IP addresses in maybe public, maybe private, but they still have IP addresses through which they can be accessed from the internet, and you can hide these addresses from basically from anyone. And even if you can't access these addresses from the internet, so you share this address with many other devices, could be also the problem for privacy, because someone could track your devices in the field and their location through this unencrypted communication, especially if you have this address published somewhere. So the gateway solves this problem, because everything goes through the gateway. If you control the gateway, then no one can see these real addresses.
So maybe also covering what you said, that the devices can be exposed on the internet. Maybe it's also, you can cover a little bit what we discussed previously about the, there is the browser where you actually can check whether your devices, especially it's in a lot of companies, the printers are treated as a gray zone, because nobody feels responsible for the printers. But actually it can be a huge vulnerability because they just we've seen, can be left out open on the internet. I guess this is also something that this particular standard can solve through this gateway architecture.
I'm not sure if you can use Web of Things for printers. Probably this is possible, but I think you will not be able to print anything through this gateway. So maybe they can implement this standard for some status checks. But the architecture, this architecture with the gateway is really we think this is how Internet of Things and Web of Things should really be implemented, because you can't bring all your devices to the internet with their real IP addresses. It doesn't work in the current state of the internet, because they're too exposed. It's too easy to execute denial of service attacks. It's too easy to hack them, because these devices are really tiny, and sometimes you don't have enough memory to implement all the security. I mean, up-to-date security, the same security as servers do.
Right.
And gateway really helps to hide these addresses. As for the printers and the threats that they cause, there is a search engine for Internet of Things devices. It's called Shodan. I think it was created long before this standard. The idea of this search engine is to search everything that is not a web page, basically. So you search the internet for routers, for printers, for any IoT device that can speak IP protocol, and then through this search engine you can see the exposed ports. You can see what kind of device it is sometimes, because if you connect over SSH or Telnet, you usually see the banner, even if you can't log in to the device. And via either means, you can guess what is this device. It's open search engine. You can check for yourself how many printers are exposed.
Right.
You can type your model of your printer and see how many printers have public IP addresses. But this is really this is neglecting the security.
Sure, of course. And also, right, I mean, it's mostly used by researchers and hackers, I guess, because also it's a nice tool to see the exposed devices out there. And again, just as we said before, also a nice tool to check the security of your company. We just had a discussion with one company in the north of Germany, and they've been hacked through an alarm system, which was not in a separated network and connected to the main system of their company. And so such a very sophisticated attack. So this use cases are possible.
Yeah, but, the most interesting thing about this search engine is that it shows how not to do the Internet of Things. Because when everything is exposed, even if it's a router,
Yeah.
no, everything should be closed from the internet. And I can't imagine how people mess this up, because by default, this is how routers work. So everything from outside is from global network, everything is closed. All ports are closed and you can't access it by default. So there is some reason they do this configurations and make vulnerable configurations. Probably they should have used VPN or something like that to access these routers, but maybe they don't know about this, or yeah, it's bad security practices. Of
Right.
course.
I guess connected to some of the things that we also discussed before about how sometimes complicated it is to actually configure VPN. And so here we link the video where we discussed the VPN before. And also what will be maybe interesting for, so we talk about Internet of Things, which is kind of a very nice idea, which is seen in this browser, because I think the only thing where you can see the Internet of Things right now, it's on this browser. I actually want to talk because you mentioned the IP addresses. So maybe you can speak a little bit about how it's done today, like which kind of addresses normally the devices would get, and also cover the interesting topic of IPv6, because initially that was also the premise for the creation of IPv6, the thinking of so many machines will go online, and that's why, you know, to increase the IP address space, the standard has been published. So maybe you can cover it a little bit, because I think it's very interesting with regard to Web of Things and IPv6 topics.
Yeah, unfortunately, we learned that IPv6 doesn't solve these problems, and we learned it from actually our partners in that work in this space, that basically sell IP addresses, and they explained exactly what is happening, why the IPv4 space is shrinking, and why IPv6 was created, and why it was not really a solution to the problem. So the problem that I describe is that IPv4 and IPv6 addresses are sold in batches, and the smallest batch is 255 addresses for IPv4, and for IPv6 I believe it's the whole /64 subnetwork. It's astronomical number of IP addresses, so probably each company needs only one such subnet. And the problem is that many small businesses, they need only maybe one or two IP address, and they can't buy them. They have to buy 255, and they pay for 255, or they just resort to using like cloud or whatever, like high level providers of networking and maybe resources. So it's more high level service than just one IP address. And IPv6 doesn't solve this problem for them, so they even offered even more addresses at a cheaper price, because no one buys it, and they can't solve their problem with these addresses. Another problem is that that I learned from other sources is for private individuals. The problem is that if you use IPv6 and you want your let's say you have some servers, home servers at your place, and some home servers at your parents' place, and you want to connect them. So IPv6 might be an answer to this problem. But again, when you get the internet from your internet provider, they give you their chunk of these IPv6 addresses, and when you change your provider, then you are given another chunk. So your addresses are not global, really. And so
Surprise.
So I don't know how this should work. How it's supposed to work? I think the system is not it's unfinished. So it's not at least it's not solving the problem that we see with small businesses and even with private individuals.
I mean, right, for us, when we learned it, it was also like an interesting fact that a lot of companies, I'm not sure how it's for you today, but also don't realize that they have this space. They just think they have, one address, and they actually buy more spaces and aggregated thousands of addresses throughout the time. So what they are doing, they are literally calling these companies sometime to even educate them that they have these addresses. And it's funny that the same problem was taken to IPv6. So what is happening, right? We are not using the resources on the IPv4 address space correctly. So we took it to IPv6. And I guess my feeling was they can't sell it because I guess in the grand scheme of things, the sale of one sub address, in their opinion, would be too expensive, I guess, because all the paperwork that is happening around this little address is complicated.
Yeah, I also think so. They just like all these people in this space. Well, they should move on to some modern technologies, and some people say that blockchain is an answer to this. I'm not sure. Maybe it's since these people are accustomed to these old ways, it would be a huge leap for them to transition to cryptocurrency. Yeah, maybe there is some middle ground that can be that can be achieved, and that can be useful for everyone, for businesses and for private individuals, and also for people who sell the addresses, because they also they lose money because they have to sell a lot of like two order of magnitudes more addresses than actually the client needs.
Right. That's tough. and what is, like, we talked about this kind of misusage. How do the devices then identify today on the, like, if we talk about IoT, if they are not behind the gateway, like how are they, they would have dynamic IP addresses on the mobile networks. Maybe you can talk a little bit about it today, how people or manufacturers actually identify their devices in the field.
Yeah, sure. If the device is in the field, then they use mobile network probably. And if this is the case, you have several options. Either, like, the simplest option is that your device have the dynamic IP address, which is given by the router on the tower, on the cell tower, or whichever it is located. Some companies provide like virtual routers, which are located actually in the cloud. But anyway, you are given some dynamic IP address. It's probably not public, but there is a public address of the router. Actually has the public IP address, and that's why someone could, if you access some servers, they can track you. And this is the simplest option. This is the default, and if you want a little bit more security, you can get a static IP address. Since this is only for businesses, you will not get like one static address. You will get the whole APN, so access point network, and this network will be it will be your network. It's private network. All the devices in this network will get static IP addresses, but they will not be public again. And as far as I know, these networks are created with IPsec technology. So they have some security, but since this is provided as like an option, you don't control the security, and you live with whatever your provider offers. And the final solution, like the third solution, is to use use VPN. So you use the first option, but you install VPN on top, then
Right.
you get private. It's the same as the second option, but you get your private network that you control, and you have all your private keys, and of course the security is and privacy is much better in this network because you are in charge.
Understood.
So yeah, this is how it works right now for devices in the field.
Got it. So just to also starting to summarize a little bit, because we started to talk about the Web of Things or Internet of Things, what is the, like, do we actually see this today? Is it heavily being used? Because like, I guess, you know, the term of like Web of Things, Internet of Things, like, I don't know, we as users might think everything is connected, devices can talk. You know, I need to say, we are recording this podcast in Germany. I don't see as a user, apart maybe from, you know, smart home use cases, a lot of things happening outside, you know, with regard to Web of Things. So maybe you can cover it a little bit. Where are we standing with Web of Things from your point today? And we already discussed the challenges and things that don't work. But maybe from your feeling, like what is it? What is it today? What is Web of Things?
From my perspective, Web of Things as a standard have failed because the IoT as a new movement also failed. And the reason is that there is no such thing as the Internet of Things. There is no. Usually, you hide your things from the internet. It's too dangerous to expose them, and you want to hide them. You want them to have private IP addresses. You want them to be accessed only via gateway, because the gateway can be protected, but other devices probably not. And the same problem, and since there is no Internet of Things, you don't need the Web of Things. You don't need the standard way of accessing devices, because you can use non-standard way, and since you are doing everything by yourself anyway, you will access them with whatever protocol they use natively.
Right.
So maybe this could be a good idea to use Web of Things for search engines. Yeah, so if you imagine a search engine for IoT devices, which is actually private, not like Shodan, which shows you exposed devices, but really private engine for that will search the API gateways that that implement the Web of Things standard. This could be probably be a good idea, but since there is no such thing as the Internet of Things, and there are not so many gateways, this standard has failed.
I think what we also learned, maybe it's also true to say that, like very advanced, I guess, with regard to the Web of Things, because when we talk about the web, we talk about the services, right? And it's also a little bit of a pickle today with regard to IoT. Like, you know, there are not such a variety of services that IoT can offer. Apart maybe from media platforms, because media platforms is always the first ones, like the set-top boxes, and then this you know, any type of like a small dongles that, you know, that have been developed. But this is, I feel, a little bit different area. So like they're not included in IoT. They are more really with, you know, part of the media vertical. And they're very advanced, and they're using browsers as execution environments, etc. But, you know, we feel also, with regard to our experience, IoT is also everything. And right now we see it more and more, right? Like, you know, cities start to have smart lightnings, and I don't know, the banks are using, you know, hardware wallets. It's also IoT somehow. The payment terminals, etc. So maybe also from this fragmentation and variety, it's also you know, really hard to do one standard for everything. And as you said, you also don't want to expose these things. Basically, I mean, that's kind of maybe a nice idea that I can print something while I'm at work on my printer at home. But I guess it's like the real use case is also not there for Internet of Things, right? Because it's mostly local use cases that you can that you can execute?
I think the industry went the other way. If they followed the idea of Internet of Things, they would have created the probably new kind of internet. Would have to create new kind of internet where the communication is end-to-end encrypted, and you can easily protect all of your devices with simple firewall rules. However, the next step would be to create a search engine for devices, and then you can create all the services on top. But the industry went the other way. They created, they approached it from inverse direction. They created the services in the cloud, which are connected to some specific devices, and under the cloud they probably have a VPN that is also through which these devices are connected. And under the VPN they have this old internet with all of its problems, etc., etc. And now we need to unfold all these layers, go back to the first layer, and then create it the proper way. And then you can have the search engine. Then, so if we create the internet that is only for things, only for IoT devices, so basically anything that is not a website and not a server, then and if you can protect easily the devices on this like new internet, then suddenly all the services are really easy to implement, because you don't need all these layers of like a VPN, a cloud, an application that can speak to the devices. Then you can gradually standardize all the communications, like at least for each type of device, like for each printer, for each router, for each smart light, whatever. You can create standard protocols, not necessarily the Web of Things. You can, Web of Things is just like for everything. But gradually you can create standards, and then you can easily create services, and then businesses will not spend so much money to create or to buy the cloud service and to basically do everything from scratch.
Understood. Thank you. I hope that we were able to uncover important topics. So we had a conversation about what is Internet of Things or the Web of Things standard. We talked a little bit about the IP addressing, which is also very important with regard to the rise of IoT economy. So thank you so much for listening. We, as usual, put some questions or topics that you would like to discuss in our next podcast series. And see you next time.
See you.
Bye-bye. To learn more, please visit our website, staex.io.